Dear students, in this video we are going to see what is isomorphic graph. Now, what is the definition for isomorphic graph? Suppose G1 and G2 are said to be isomorphic. The first condition is if there exists one-to-one onto functions. The functions are f and g. The function f is defined from the vertex set of the first graph G1 into the vertex set of the second graph G2. The function g is nothing but from the edge set of the graph G1 into edge set of the graph G2, such that second condition is an edge E is adjacent to vertices V and W in the graph G1 if and only if G of E is adjacent to f of V and f of W in the graph G2. We will see how the isomorphic graph conditions works in the given problems. For example, now you see, prove that the given two graphs are isomorphic. Now this is the given graph G and this is the given graph H. We have to check that whether these two graphs are isomorphic. Now first, what we have to list from the given graph G. Now this is graph G. You count the vertices 1, 2, 3, 4, 5, 6. So total number of vertices 6, and list all the vertices in the set, that is V of G, U1, U2, etc., U6, and you count the edges, that is 1, 2, 3, 4, 5, 6, 7 edges. Yes, 7 edges. So 6 vertices and 7 edges in the graph G. Now take graph H. 1, 2, 3, 4, 5, 6. 6 vertices in the graph H. Now list all the vertices of graph H, that is V1, V2, V3 until V6. This is the vertex set of the graph H, and count the number of edges. Here 1, 2, 3, 4, 5, 6, 7. So number of edges 7. Okay. Now what we have to check first, the number of vertices in the graph G is equal to number of vertices in the graph H. Yes, here how many vertices? That is 6. In graph H, how many vertices? 6. Okay. Now next, you check how many edges in the graph G. 7. Similarly, the number of edges in the graph H also 7. Okay. Now we can form the function from the graph G into H. We can form the function for vertices and we can form the function for edges. Now you see here, before that we have to check one more condition. Now you see here, in the graph G, for the vertex U1, you take this U1, the vertex U1. For U1, what is the degree? You see here 2 edges incidence with the vertex U1. It is here, this is 1 edge, this is 1 edge. So what is the degree of U1? It is 2. 1, 2. So degree of U1 is 2, degree of U2 is 3, degree of U3 is 2, degree of U4 is 3, degree of U5 is 2, degree of U6 is 2. Similarly, just you can write for the graph H also. Just write the degrees of each vertex of the graph H. Now we have to check the matching of the degrees of each vertices. For example, you see here with 2 degrees in graph G. I am talking about graph G. With 2 degrees, how many vertices here? Now you see 1, 2, 3, 4. You check in graph H now. 1, 2, 3, 4. So here in graph G, 4 vertices with degree 2. Similarly in graph H, 4 vertices with degree 2. Okay. Now here with degree 3, two vertices. Here 1, here 1. Two vertices of degree 3 in graph G. Similarly here two vertices of degree 3 in graph H. So what we have to do first, 3 points. First you check number of vertices in G, number of vertices in H, whether both are matching. These numbers are same. Okay. Second, check the number of edges. Yes, same. Okay. Now next we have to check the corresponding degrees, means how many 2 degrees, how many 3 degrees, how many for example 4 degrees, whether it's equal in the given two graphs. Okay, now we have to do mapping. What is mapping? Now you listen here. F of u1 is equal to v6, which means the vertex u1 from the graph G is mapping the vertex v6 in the graph H. Okay, suppose I am not taking v6. For example, we will try. Suppose I am not taking v6. I am taking v1. You see here, I am taking v1. Okay, now u1 is here. u1 in the graph G is here. You suppose we check the vertex v1 to map with u1. Okay, now what are the things we have to check to map the vertices from one graph to another graph? Now you see here, for u1 first you check the degree 1 2 two edges incident, so here the degree is 2. Okay, now you check for the vertex v1, degree is 2. Okay, now this is the first point. Okay, now what are the adjacent vertices of u1? We have to check. See, now for u1, what is the adjacent vertex? Here u2 and here u4. Now for this u2, what is the degree? 3. Now for u4, what is the degree? 3. Okay, what I am doing now, I am mapping this vertex u1 with v1. Just I am trying. Okay, now here if I map u1 and v1, see the adjacent of u1 having degrees 3 and 3. Now here, what is the adjacent vertex of v1? First one is v2, that is degree 2. Now for v1, another adjacent is v5, that is degree 3. Now can we map u1 and v1? No, because here for u1, two adjacent vertices having the degrees 3 and 3, but here for v1 the adjacent vertices having the degree 2 and 3, so you cannot map. That's why I have not tried with v1. So now check with v6. Now u1 and v6. Okay, that is here u1, for I put 2 tick, u1 and v6. Okay, now you see here, for u1 we have two adjacent vertices u2 and u4 having degree 3 3. Now for v6 we have two adjacent vertices v3 and v5. Here for v3 the degree is 3, for v5 degree is 3. Now we can match, because the adjacent vertices of u1 having the degrees 3 3, adjacent vertices of v6 having the degrees 3 3, therefore we can match. That's why we are writing f of u1 is equal to v6. Okay, now you see the second one, for the second vertex of the graph G, that is f of u2 is equal to v3, which means I map the vertex u2 with the vertex v3. This is this vertex from graph G, this vertex from graph H. Okay, first we have to check the degrees of these two. For u2, what is the degree? 3. Okay, for v3, what is the degree? For v3 is 3. First, okay, we have to check the degrees of the first map. What are the vertices we are going to map? This 3 3. Okay, we can try. Second, we have to check the adjacency and the corresponding degrees of the adjacent vertices. Now, okay, for u2, what are the adjacent vertices? Now you see here u1 degree 2, here u3 degree 2. Okay, now for v3, what is for v3? Here adjacent is 1 2, 3. Here also 3 adjacent. This also. U6 also adjacent with degree 2. Okay, now 2, 2, 2 for the vertex U2, 3 adjacency, that is U1, U6, U3, that is 2, 2, 2. Similarly here for V3 we have V2, V6, V4. Here vertex having degree 2, here degree 2, here degree 2. So now okay, we can map U2 and V3. That's why we are writing here f of U2 is equal to V3. Now, and one more thing, this is the mapping for vertices. Okay, for edge, no need to write the mapping, but automatically it will. Now, how we can understand that? Now you see here for U1, what are the adjacent? U1, this is adjacent vertex, the adjacent vertex. What are the incident edges? This one and this one. Okay, first edge, second edge. Now for V6 in this graph, for V6, now this one, which edge is going to map? Actually there's no need to check and write here because we are going to use the adjacency matrix for this. So we can write only for vertex. Automatically it will be means matching the edge also, but just I am telling you. See here, this edge is mapping with this edge. Why? Now U1 is mapping with V6, this one. So next U2 is mapping with V3. So now U1, U2, this edge. So similarly V6, V3, this edge. So why I put one single line, this edge and this edge is automatically having mapping. If you do the proper mapping for the vertices, definitely it will map for the edge also. Okay, now similarly you see here U1 is mapping with V6. Okay, then here the adjacency of U1, that is U4 is mapping with V5. So now here V5, so U4 is mapping with V5. So this edge is nothing but is getting mapping with this edge, so that if you form a good mapping for the vertices, automatically you will get a good mapping for the edge also. Now we can make the adjacency matrix. Okay, first we see the adjacency matrix of the graph G. Now U1, U2, U3, U4. So now write all the vertices in row and column. We know that how to make the adjacency matrix. For example, for U1, what is the degree here? 2. So you will get 1 plus 1, 2, degree 2. U1 is adjacent with U2, so put 1, because U1 adjacent with U2, so put 1. U1 adjacent with U4, so put 1 here. The matrix is symmetric, so write this here also, because if U1 is adjacent with U2, I can say U2 is adjacent with U1 also. So here you put 1, so that I can put here also 1. That's it, symmetric. Similarly, you can make the matrix. Here one important thing, now this is the order U1, U2, U3, U5, U6. Here when you do the creation of the mapping U1, U2, U5, U6, so that I can write same order. Now you see what is the order here? V6, V3, V4, V5, V1, V2. You have to write the same order, then write the adjacency matrix from this graph H. Definitely two matrices are similar, therefore we can say that adjacency matrix of G is equal to adjacency matrix of H. So from these two adjacency matrices we can say that the graphs G and H are isomorphic. After mapping this, that's it. Now see another example, prove or disprove given graphs are isomorphic. Now you see here, check number of vertices, 5, 5, same. Number of edges, same. But you see the degrees. You see here, no vertices having degree 1 in the first graph G. But here, this vertex E having the degree 1. So we cannot make the mapping. Now that is the reason. But here H has a vertex of degree 1, whereas G has no vertex of degree 1. Therefore we cannot make the mapping. Or we can say another reason. Here two vertices having degree 3, but here one vertex having degree 3. So that we cannot make the mapping. That's why these two graphs are not isomorphic. Thank you.